Welcome to a new video in my home automation series, and I think I mentioned in a couple of videos that I want to play a little bit more with Meshtastic and I want to understand it a little bit better how it works. And as usual how it happens on my channel, I'm coming this from a smart home or home automation angle, and I wanted to use something in the Meshtastic system or firmware which is available, which you can use these Meshtastic nodes for environment metrics. So you probably have seen a lot of videos on how you can use Meshtastic for text communication and offline communication, completely separate from the internet. But they do also support all sorts of telemetry functions. Of course, each of the nodes can report like, battery state and GPS coordinates and that sort of stuff. But you can actually hook up sensors to these devices, and then those devices can report the values of those sensors. And what you can see here on the right, on the left, yeah, that I have an environment sensor. I mean, it's a BME2680, I think I used, and it's outside in the garden shed, and it's measuring temperature and humidity, and I'm able to get this in Node-RED. So in this video, I'm going to focus on how you can do this, how you set this up, and actually also going to talk about a couple of options how you can use Meshtastic to be used as a sensor network and how to get this information into Node-RED. And there are multiple ways of doing that. I picked an option which has some limitations, but it also means that it's very easy to do. It doesn't require you any coding, firmware modification, additional microcontrollers, so it is very easy to use. And it took me a couple of months to get it working because I was missing some of the information, but the Discord, Meshtastic Discord, was actually a lot of help for me. So I'm starting this whole Meshtastic journey with this single video, but then since I got the basics working, I've already ordered a couple of different sensors. So I want to play around with how you can use various sensors, maybe how you can make like a solar powered node, and also maybe do some, tests as well. How far I can place these sensors out and what sort of range I can get with them. But there are a lot of other options in Meshtastic, so I definitely want to explore that. And again, as usual, look at it from a smart home angle and then see how we can use it for various scenarios, gathering environment metrics or maybe even controlling some stuff around the house where your Wi-Fi coverage is not sufficient. And again, the reason I'm starting this because there are many cases where there are places around the house where you cannot get Wi-Fi coverage, so you won't be able to create an automation or create a sensor or control something using Wi-Fi because it's just outside the Wi-Fi range. Of course, you can do Zigbee, but they pretty much work on the same frequency, so the limitation is going to be somewhat similar. Maybe in some cases it's actually easier to extend the Zigbee range by another router, but that can also only go a certain distance. But on the other hand, Lora works at a different frequency, a lower frequency. It is designed for a longer distance and a low bandwidth communication, means that potentially it would be easier to cover a distance with Lora than it would be with Wi-Fi and Zigbee. And of course, cost also comes into the picture. And I mean, I ordered quite a few Lora capable LilyGo boards a couple of years ago. I seem to remember that it was much cheaper. I mean, I looked at AliExpress and it looks like that any Lora capable board starts around like 30 USD at the moment. I thought it would be cheaper. I mean, I'm thinking about like buying ESP boards for a tenner or less. So maybe in price is going to be comparable with Zigbee, but again, it's a different infrastructure. Maybe in some cases it's going to be easier to go the Lora way, and then once you go Lora, you can also do Meshtastic, because you can definitely build your own Lora network. You don't really have to have Meshtastic for it, but I think since there is a good framework that we can use, and it also supports a mesh network, I think there are potentials, and it's definitely easier to start with as opposed to writing your own code from scratch. And actually there are a couple of different ways how you can create sensor nodes in the telemetry network. I mean, maybe, specifically I've looked at two different examples that, I found YouTube and on the internet. So the one example is that you have a, let's say, an ESP based chip, which is running Meshtastic. And then you have a second microcontroller which is connected to some sensors, and the two microcontrollers are connected together because in Meshtastic you can connect a separate microcontroller to the, let's say, the main microcontroller, and then it would be able to relay messages back and forth between them. So for example, you have an example where you have the, let's say, an ESP32 which runs Meshtastic. You have another Atmega or any Arduino board which is reading the sensor, and it sends the sensor data to the ESP node, but that message is getting sent as a text message, like somebody typed in the the temperature, the humidity, but then that can be any sensors, any number of sensors, and then you can format the data you wanted, and then you send the actual reading as a text message. And well, this is fine, but I'm trying to make it even simpler by not having to integrate another microcontroller, write another sketch for that specific microcontroller, because there is this other options, which is the telemetry module configuration in Meshtastic. And then what it does, it allows you to connect an I2C based sensor into your microcontroller which is running Meshtastic. So everything is going to be handled in Meshtastic. So I'm going to show you how it works. So in my network, I have this sensor node that you can see here. And you can see in the Meshtastic screen as well that it shows a temperature and humidity and an air quality index. And if I click on this, then if I scroll down, you can see that I have some environmental metrics. So I have temperature, humidity, dew point, pressure, gas resistance. So this is coming from a BME 680 sensor. And actually you can also go into, you have a separate screen as well, environment metrics log, and you can even see how this looks like. The reason it's it's truncated because my phone wasn't connected to the Meshtastic network all the time, and hence it doesn't have information for a long time ago. But you can see that it was more or less connected in the last 4 weeks. So this is how the values change. So this graph is being generated by the phone, so it collects the data on the phone. So there is a good overview of this sensor data on the Meshtastic app. And again, the reason I like these options, because I think there is a good list of different sensors that are supported by Meshtastic, and here you don't need to make any changes to coding or anything like that. Basically, you just take the node, let's say the ESP32, like a LilyGo board. I mean, I think in this case, yes, I'm using a LilyGo Lora module. You look up the documentation, you look which legs are the I2C, SDA, and SCL pins, and then you connect the one of the supported I2C sensors, and of course you connect power and ground as well. So literally it only takes 4 wires to do this. No change to the no change to the code is required, and it takes like $5 or $10 to add this functionality to any of your Meshtastic nodes. I think it's a much easier option as long as you are okay to use one of their supported I2C sensors, meaning that it satisfies your criteria what you want to measure. But I'm just going to show you what these devices are. So I think this is a great option. This definitely was easy for me to do. I mean, of course, you have to do a little bit of configuration, hence this whole video, but I don't think it's complicated, and it's fairly easy to get everything up and running. And so I was able to get all these different sensor data into Node-RED without doing really much configuration. Without doing really much programming. It was just really going here, enabling settings, making sure that the Wi-Fi and MQTT credentials are correct, and after that it was up and running in no time. And before we continue, let me just illustrate how this works in a diagram. So we have a LoRa network which consists of many different LoRa devices. These are these brown thingies. and they create, well, Meshtastic says it's a mesh network, so they communicate over the LoRa wireless protocol. And the reason this is a mesh network, because if you send a message from one of the nodes, then it gets retransmitted by other nodes until it reaches the destination. And of course, there are some limits and some other settings and probably some timing just to make sure that a single message does not overwhelm the network. But that's the basic concept. So these messages are being transmitted across these nodes. And so if you want to cover a bigger distance, then you put a node in between, just like with any mesh network, and that it becomes like a repeater or a router for that message over to a node which is much further away. And normally in the Meshtastic network, you have a phone or a laptop, and then you connect it with to any of the nodes using either Bluetooth or serial or Wi-Fi. And that's how you can use your phone to send messages and use the phone to receive the messages. And also, of course, you can, most of these devices have a screen. Some of them have a keyboard as well. So you don't necessarily need a phone, but usually if you have like a very simple device, which maybe just have a screen, you can use the screen to look at the messages, but then, you open up your phone to, in order to, send messages or, look at the chat or anything like that. What we are going to do here is we are going to use that basically concept. So we have, in my example, I'm going to have two nodes. And you have to have at least two nodes for this whole basically topology, because you have one single node, this one, which is inside your home Wi-Fi coverage. So that is going to act as like a bridge or a gateway between the LoRa network and your home network, which is, MQTT and, in my example, Node-RED. So this device is also configured to be connected to the Wi-Fi, and of course it has the LoRa radio, so it is connected to the LoRa network using Meshtastic. And then you have the other device, which is, let's say, more further away. It's outside the Wi-Fi range, but that has the sensor connected to it. So it reads the sensor data, and it periodically transmits a telemetry data over the LoRa network, over Meshtastic, over LoRa to the other device. So this device, which is in the Wi-Fi, is configured that every message it receives, it relays over Wi-Fi to an MQTT server. And of course, once it's received by the MQTT server, then we can get this information in Node-RED. So the concept is very simple, and in order to make this happen, we have to do a couple of different configuration options on these two different nodes. And of course, you have to have Meshtastic running on these, and the Meshtastic needs to be configured. And I'm not going to go into that details. Maybe I'm going to cover it in a future video, but there are plenty of videos which is going to explain you how you can get your, Meshtastic compatible hardware and how you can flash Meshtastic and do the initial configuration. So the first thing that we need to do is, I'm going to show you all these steps a little bit later on the phone as well, is obviously the node which has the Wi-Fi coverage. It needs to be connected to the Wi-Fi network, so it needs to be configured for Wi-Fi. And also in the module settings, you can also set up the MQTT connection. So it's the usual stuff like what's the broker address, user ID and password. And then also on the channel configuration, you have to tell it that it should enable the uplink. Well, I enabled uplink and downlink as well, but for the time being, we are going to use uplink. So that basically just says that everything which is received on the LoRa network, it will push it to MQTT as well. And with this, we are not done because we also need to configure the remote node as well, because it also has a message which says that whatever message is sent, it is okay to be forwarded to MQTT. So that has to be configured on every single basically end device, just to make sure that that is also enabling its data to be forwarded to MQTT. So I think they designed this way because let's say you go into a foreign network and you have a node which has MQTT enabled. It's just not going to automatically push every single message out to the MQTT, because the other clients sort of have to agree that the data is getting exported to MQTT or something like that. I'm guessing that's the reason behind these decisions. And first I'm going to show you the Wi-Fi node configuration, and for this I have actually typed the IP address of this Wi-Fi node, which is on this IP address, and this loads this client interface, which you can use to configure any Meshtastic device. So I'm just going to set up a new connection, and I'm going to connect it locally, and that's going to load the basically the administration. It's saying what you can access on the phone, but this node is a little bit further away from me. I cannot connect it using Bluetooth, and the remote configuration is not enabled. So this is why I'm using this. Okay, so sometimes it takes a little bit of time for this to load because it's, you know, loading all the information from this node. But now we can go into config and then network. And here you can see the network configuration. So it's the usual thing. Okay, what is your SSID and what is the password? And you can do some additional configuration. I mean, normally you can leave it on DHCP, but I configured a fixed IP address, so you can do that as well. And to be honest, I haven't really changed anything on the rest of the screen, just configure the SSID and the password. And now we can go into the other configuration, which is in radio configuration and MQTT. This is the first one. So again, you enable the MQTT configuration. You have the your MQTT server, so IP address, username, and password. And two things I've done here, I enabled the JSON format because it's just easier for me to process the JSON in Node-RED. I defined a root topic. I just named it Wi-Fi because the name of the node is Wi-Fi. So MSH/Wi-Fi. And I left all the other settings on default. So now what we need to do is we need to go into the Lora configuration, which is if you go up into channels and then you have the primary channel. So all the telemetry messages are getting pushed out on the primary channel, and then you just select uplink enabled. I enabled downlink as well, but for this exercise, as I said, we are only using the uplink. And that's it. And don't forget to, you know, submit the changes at the bottom of the screen. So this takes care of the configuration of the Wi-Fi node. And I'm also going to show you how you configure the other node, and let's just pretend that this is the, you know, the other node which has the sensors in. So again, you access the same interface on your phone or on, you know, Wi-Fi. Sorry, well, not Wi-Fi because that's not going to be connected to the Wi-Fi. But if you bring the sensor in and you plus, and then you can also connect using Bluetooth. But then you go into the config again, and then radio config, and then Lora. And by the way, this is where you have been when you initially set up the mesh network, or sorry, this mesh node to be, you know, on what region and everything. And here you have this option which says OK to MQTT. So that's the one that you need to enable on the device which has the sensors on it. And I'm going to show you this in my phone app as well. So here, these are all my nodes that I have. So the M2 is very close to me. So I'm going to use this for, you know, testing. So it's we just wait until it loads everything, and then I go into radio configuration, Lora, and then we just wait, and then yeah, we have the modem configuration, and that's the one. So OK to MQTT. So that's the one which is enabled, and of course you send once you made the changes. And before we go into the actual configuration, I want to show you what this telemetry module is capable of doing. So the way it is designed in Meshtastic, that it basically supports sensors that are on the I2C bus. So it won't be able to support all sorts of sensors like, you know, one-wire sensors or DHT22s. It has to be some sort of I2C sensor. And also there is like a fairly extensive list what type of sensors you can select. So you can always pick and, you know, choose what is the best option for you. I mean, you know, there are sensors that have, you know, more, you know, sensors built in. For example, the BMP 680 has, you know, humidity, pressure, barometric pressure, and air resistance. You know, sometimes you don't need all this information. Maybe you only need temperature and humidity. So you can choose another sensor, which again could be cheaper to purchase. But as you see, it pretty much supports all the BMP and the BME series. I mean, to be honest, I usually use BME 280, BMP 280, or 680 if I need the air resistance. So you can see that you know, these cheaper sensors only have temperature, pressure, but they don't have humidity. So Yeah, there are a lot of different ones. So basically there is a lot of, temperature, humidity and pressure, that sort of related sensors. You also have this one, which is just, temperature only. You have the SHT series, which again, temperatures and humidity. And then we have a couple of sensors which can also detect light and also UV, so light intensity. I think these are also very good options where you don't have to set up some automation based on the ambient light level. Although I don't think that would necessarily need a LoRa sensor, because you can probably place that within the Wi-Fi coverage as well, but it might depend on your application. And also you can see that we have a couple of current and voltage sensors. So again, it's a good idea if you have something which you want to monitor remotely, the voltage and current, it's outside the Wi-Fi range, you have this option as well. And also we have quite a few interesting ones. So for example, there is an ultrasonic distance sensor, which is I2C. So again, tank levels, that could be great to do. And then there are a few sensors from DF Robot. So there is this DF Robot Lark, which is like a weather station. As you can see, it has temperature, pressure, humidity, wind direction, and wind speed. So that again would be useful if you live in an apartment and you want to have a if you live in an apartment block and you want to have a weather sensor on the top of the roof, which you won't be able to access, not even power, but definitely not Wi-Fi, then, you can probably cover the distance with LoRa. And also there is a rain sensor. So this is the tip bucket counter, which I think it's also quite good, because again, you might need to place these sensors, far away from your home, where maybe it's not under the trees, so it can, measure rainfall. But I'm thinking that maybe these type of sensors can be repurposed as well as an input counter. So for example, you can mount it on a water meter, which could be, done in a, underground something, in a, I don't know how it's called, these not bells, but these things that go underground, or some other, meters that could be, far away from your building, because they usually have like a rotating magnet, and they also use Hall sensors to detect these, these sensors going through or, rotating. So maybe these DF Robot Rain can be used for that purpose as well. And also you have some other, body temperature, dosimeters, heart rate. I'm not sure how much they would be, useful for LoRa and home automation, but yeah, you have these sensors. And also one more important thing that I want to, I almost forget, is it's okay that you link those telemetry modules to your LoRa, your base LoRa ESP module, but you also have to enable the telemetry module, so it actually starts looking for devices on the I2C network. Okay, so I would just walked over to the sensor, gone into the configuration, I've taken a screenshot, so you can see that I have enabled the telemetry. I have also enabled that it shows on the screen. So that little screen on the ESP module also shows the temperature and the humidity, and you can also set the reporting interval, which is the default is the 300 seconds. You can make it longer if this is like a solar panel node, or I think probably I wouldn't take it shorter unless it's really, really important, because you don't want to necessarily flood the LoRa network with messages. And I think after, all this is configured, all the different mesh nodes are configured and everything is up and running, then, we are pretty much ready to receive messages. So, by the way, you can read about this MQTT integration here in the Meshtastic node, Meshtastic documentation, what sort of topics it creates, and, the type of messages. And again, through this integration, you would be able to receive text messages, but I want to focus on the telemetry at the moment. So I have MQTT running as well. So I'm going to show you, maybe I'm going to change view so we can see it in full screen. So how this looks like. So if you remember the MQTT configuration, I configured that the messages are coming through MSH and Wi-Fi. And after that, there is a region. For me, it's always going to be 2. And then we have 2 more subtopics. There is an E, where it contains the original binary data that comes through, and then the JSON, which puts it into a more human readable format. And This is why I said, enable the JSON, because it's going to be much easier to recognize that. And then we just happen to have a reading which is actually coming from these sensors. So you can see that it came in channel 0, which is the primary channel, and it came from this device. And yeah, you can see that's the barometric pressure. There is a gust resistance. So again, that's coming from a BME 680. And we have the humidity here, and we have the temperature. And you can see that it contains all sorts of other values that are related to some of the other metrics that other sensors can provide. So I think this format is, it's going to be the same for every time a telemetry message is sent or an environment message is sent, but then it will contain different set of values based on the sensor or sensors that are linked to that node. Because again, on I2C, you can hook up multiple sensors. There is one important thing to remember here is, so now we are receiving all these messages through that node which is connected to the Wi-Fi. So everything, regardless how many nodes, environmental or sensor nodes we have on the network, all the messages are going to come through this, well, in my case, is the MSH/Wi-Fi. And then this ID, this exclamation mark, 08 something, that's also an ID for the Wi-Fi, that Wi-Fi node where the message is being extracted from the Lora network. So what we need to actually look at is this from in the message. So that, tells you what node this is coming from. So again, if you look at my, my Meshtastic app, so this is the node which has, so I have the M2, which is, just something that I need to connect to, and that's the Wi-Fi node, and this is the sensor node. So if I select the sensor node, and if I click on it, you can see that there is a node number, which is the 145458772. So you can see that's the same number as here. So if you have more, of these nodes, then you should be looking at the from message, the from attribute from this message in order to tell which sensor send that reading. Because again, you can have, you only need one of these Wi-Fi nodes, and then you can have loads of these, sensor nodes, one measuring temperature, the other one could be a weather station on top of your house, and, maybe one of those counters, which is looking at the water meter usage. And so the only thing is we look at the from in order to tell that it's which node it is coming from. And again, there will be a lot of other messages coming through this channel. So we are also looking at the telemetry message. So the type is telemetry. And on top of these, telemetry message also contains information about devices. So hopefully I will be able to show you a data, because sometimes nodes send telemetry messages like, oh yeah, like this one. So it doesn't contain the environmental details, but it contains the airtime utilization, the battery level of a particular sensor, which actually is the same sensor node. So it will send the telemetry messages, and it will send also messages like what's my uptime, what's the voltage, and these are also type telemetry as well. So the way I figure this out is basically just, look at the payload, and if the payload contains, let's say, temperature, because I know that, only the environment telemetry message contains temperature, then I know that that's a environment telemetry message and not another telemetry message. Okay, so once we receive these messages, as I said, we have to look for a couple of different things. So let me just show you the very simple, Node-RED flow that I created in order to extract that. So first of all, I created a MQTT in, so that listens to the MSH / in my case Wi-Fi /2, which is again a region code, and the JSON, and again long fast. So long fast is the default channel or the communication, and then the ID of the node. Again, once you start receiving the messages, probably it's easier just to look at MQTT Explorer and see on which topic the messages are coming. And again, as I said, this is the topic where all your messages are going to come through text messages, telemetry messages, and environment messages, and from all the sensors that are in reach of this Wi-Fi node. So first of all, what I have done, I created a simple switch node, which I said I check the payload.from. So I want to make sure that, well, in the beginning, I'm only interested in the message which are coming from this sensor node. And then I also look at the type, the type is telemetry, because let's say that node can also send text messages. I mean, it won't in my case, but it's definitely a possibility. And then I get the environment metrics out of these. Here I used a little bit of code here, and first of all I checked if the message.payload has a temperature property. So again, I'm doing this because these telemetry messages might be those ones that have, voltage and uptime, which we again don't care about if you only want the environment variables. And if we are getting this type of message, then I just printed the values of message.payload.payload.temperature fixed to 1 decimal place, and then the message.payload.payload.relative_humidity fixed to 0 decimal places. And that's how I get this status here in Node-RED. So yeah, you have to go through a couple of hoops and then do a couple of switches and maybe a bit of coding here in the Node-RED. But at least with this, you would be able to get all these values out of the Lora network into Node-RED. And of course, as I said, if you have multiple sensor nodes, you can do like, more of these switches here. So you can add a new one, and then you can put the value of the node here. Actually, that reminds me, let me just check. I mean, technically, this should have been a number, but it still works, it looks like. Because those are actually numbers, not the, the ID is coming through as a number, not through a text. Yeah, but that's it. And this is how you get this one working. And as I said, I'm planning to, play around with this a little bit more, use more different type of sensors and then see how it looks like, maybe create other nodes. So multiple sensors are reporting these environment metrics through my mesh network, and we will see how that looks like in Node-RED as well. But I think for the time being, that's going to be all. I try to link all the different pages on my in the video description. So if you want to replicate, then you can just follow on. But I think that's all going to be for today. Thanks for watching, and hopefully see you in the next video.